right, this is video 3 in our series of videos on pedigrees. So to help you decide the mode of inheritance, the pattern of inheritance of a trait, we've already talked about how to decide if a trait is recessive or dominant. And now we're going to learn, how do I tell if a trait is autosomal on a body chromosome, an autosome? And we learned that the autosomes are chromosome numbers 1 through 22. X-linked, of course, is another word for sex-linked, and we know that that is talking about the sex chromosome. That's the 23rd pair of chromosomes. We know that if you have an XX, you are a female. If you have an XY, you are a male. So these autosomes determine a lot of your body characteristics, eye color and hair color and so forth. So sometimes if you're reading a context and it tells you that it is inherited on chromosome 7, you don't even need to look at the pedigree to look at the males and females. You know right now that that's one of those autosomes. That is any of those body chromosomes, you know it's autosomal. Okay, if they say it's inherited on that 23rd chromosome, you know it's sex-linked. But chances are you're going to be given a blank pedigree, much like this one that we have below us here. And you will have to decide, is it going to be autosomal or is it going to be X-linked? So again, you start out by looking at the number of males and females. So on our previous 2 pedigrees, on the recessive one, when we looked at that, we had 2 females and 1 male. And so again, there weren't much difference in numbers. There wasn't a whole bunch more of one sex being affected. And it looked like it came from either parent's gender, and we had an affected female, and she did not have an affected father. So we would have said it was autosomal recessive. And then in our second pedigree, the one on polydactyly, we looked through that. We had 3 females and 3 males. Again, not a big difference, right? It's not like there's disproportionate, like way more females than males or vice versa. And again, looking at all of this information, our last pedigree was dominant trait. We talked about why is it dominant, but we didn't really talk about why it was autosomal. But you can certainly go back and apply these criteria to it. So this example that we have, we're looking at here, we already talked about the fact that there's a whole schwack of males that are affected, right, in all of the generations here. And how do I know it is recessive? We talked about that. Unaffected child, 2 affected parents, and we forgot Victoria should have a little dot in the center there. And that would indicate a special thing that's called, she is a carrier of an X-linked trait. She is a known carrier. So Leopold here, this little boy, must have received his hemophilia allele from one of his parents. Now, this trait tells us that Queen Victoria, the mother in this whole family, this is the European royal family, by the way, and it goes through, and it doesn't have like Charles and Diana and all the, newer royals, but it does go and talk way back in history to Queen Victoria. So they knew that Victoria was a carrier. She was a known carrier of this X-linked recessive trait. And so nowadays you can get a blood test or something to do that. But back in the day, they didn't know that. And so a lot of intermarriages occurred. So like Henry and Irene were cousins, and they called these royal family the blue bloods because they're royal. Actually, they just spread hemophilia throughout the family. So we see a lot of offspring, boys, males, that died at early ages because of hemophilia. So again, looking at the male to female sex ratio is a very important clue. But another thing that you need to look at is, where is the X coming from, right? Is it coming from the mom? Is it coming from the maternal side of the family? So if you look at each of the affected offspring boys, they all have a mother who is a carrier. Each of them, their mom was normal. She did not have hemophilia because she had the normal unaffected allele, but she carried that recessive allele. And it was that recessive allele that she passed to her son, and that's why he got hemophilia. Now, there are no females on here at all that have hemophilia. In order for a girl to have hemophilia, she would have to have an XH from her dad. And so dad would have to be affected, shaded in, and she'd also have to get an XH from her mom. So at minimum, her mom would have to be a carrier, or her mom herself is going to be affected. So anytime you have an affected daughter, they're going to have an affected father. With an autosomal, you may have an affected daughter, but the dad does not have to be. Okay, so again, you are not only looking at is it recessive or dominant, but now is it autosomal or X-linked? So we have decided that this is a recessive trait. How did we know that? Every kid who's affected had unaffected parents. So like Frederick, for instance, is affected. Mom is not, dad is not. So obviously the parents, I don't know what that is, are going to be passing on recessive allele to the offspring. And yes, this does skip generations. So you can see, for instance, in Alice's family, that I'm just going to back up here for a second. Her mom was a carrier but unaffected. She was a carrier but unaffected. Her son Frederick had it, but her daughter Irene did not. But then Irene passed it on to Henry. So nobody had it generation 1. And in Alice's family, nobody in generation 2. But then you saw it again in generation 3. So it is skipping generations. Now, again, this symbol with the circle with the little dot inside of it is a known carrier. They're known to be having that X, big H, X, little h. Not every pedigree that you're going to see is going to indicate a known carrier. In fact, it's just going to look like this. They're not likely going to indicate that that individual is a carrier. So you have to deduce, you have to look, and you have to say, oh, well, oh boy, I see here is someone who is unaffected, yet their child has it. Why does the child have it? Well, clearly this person must be a carrier. So again, they're not going to have that little circle in there. They may just look like not shaded in circle. Okay, so this one has so many males that you're obviously going to understand that it is very clearly X-linked. And so quite a few X-linked traits in humans: red-green color blindness, some forms of muscular dystrophy. And remember that when you are doing your genotypes for these individuals, you must use X's, right? So males are either X big HY, that is normal, unaffected, no hemophilia, or X little hy. You cannot say big H, little h, or big H, big H. If you're doing that, it shows that you don't understand that this is on the X chromosome, that it is X-linked, that it is sex-linked. You would do this for an autosomal trait, but not a sex-linked, right? And so you have to very clearly understand that, and don't use the autosomal when it is actually X-linked. Okay, so you guys will have some questions to do, and so you're going to be again asked the mode of inheritance. So is it recessive? Is it dominant? And then justify why. And again, don't just say, well, because there's affected children with unaffected parents. Well, who is unaffected and who is affected? You have to specifically refer to individuals on your pedigree. Like 2-2 was affected, and parents 1-1 and 1-2 were not, right? So in order for you to justify, you have to very seriously put a lot of detail into your explanation. So the next couple of pages are some practice questions for you, how to read a pedigree and assign genotypes, and you will just follow through and do these questions. I'll post a key. Oh, this is fun. This is practice for you. You actually get to draw out a pedigree, and don't forget that you must include those Roman numerals and the individual numbers underneath it, because if you don't do that, you haven't completed it, right? You must do that to have a complete pedigree for full marks. Okay, and so you're examining pedigrees, how many generations, who's got this. And again, if you are asked for the inheritance pattern, that's where I'm looking for that mode of inheritance. Okay, so it's always going to be either autosomal or X-linked, and it's always going to be either dominant or recessive. So there's those 4 different combinations, and you have to provide your reasoning. You have to justify. You're going to go and look at and start again with the kids. Look, oh, here's an affected kid. So I'm going to, oh, one parent is affected. Okay, well, let me keep looking. Oh, affected kid, neither parent is affected. Okay, and so you look through and you got to justify. And again, refer to the individuals from the pedigree as part of your justification. As always, if you need me, I am an email away. So this week we will have a formative on pedigrees and also dihybrid crosses. You have a lot of practice to do, and yeah, this material is not easy, but it's fun and it's interesting. So do your practice questions, check your answer keys. Email me if you have questions, michelle.ledeen@ghsd75.ca. This is the 3rd video out of 3 in our pedigrees series. I'm done. I'm out. All right. Take care, guys. Talk later.